A wall has a height h and a distance l away. You wish to throw a ball over the wall with a trajectory such that the ball barely clears the wall at the top of its parabolic motion. What initial speed is required? Let's consider the limiting case where the ball is thrown close to the wall. In this scenario, the minimum speed will be achieved if the ball has the smallest possible speed at the highest point of its trajectory, which is near the top of the wall. This speed would be 0. To determine the initial speed in this case, we can apply the law of conservation of energy. From this, it follows that the initial speed must be equal to the square root of 2th. Let's consider option 1 and note that it does not even contain the dependence on the speed of the thrown distance, but we can easily guess that if we throw from a large distance, the speed should also be quite large. Therefore, we can throw out the first option as well as the second option, since it does not depend on a throwing distance. Let's analyze this third option and see what happens to the speed if we let the height of the wall approach infinity. From the formula, it follows that the speed should either become 0 or at least become very small. However, this is incorrect because as the height of the wall increases, the initial speed should also increase. Therefore, I conclude that option 3 is also incorrect. Now, let's consider the fourth formula. Recall that at the very beginning, we analyzed a special case where the ball is thrown directly next to the wall. In that scenario, the initial throw speed should have been equal to the square root of 2gh. If we consider the case where the distance between the wall and the initial point of the throw approaches 0, we arrive at the same result. Thus, we can conclude that the fourth option is indeed correct.